Now that we've entered our duty, let's click Next. Have a look at some accessories. So we can have inlet dampers, outlet dampers. If we have an inlet damper, we can select a simple shape. So the damper is made of a spindle, a round bar here with a flat plate bent over and welded to it. Or we can have an aerodynamic design, which is a diamond folded shape around the round bar spindle. So we've got the options there. With outlet dampers we have exactly the same. So if we just have an inlet damper for now, we can say also with an inlet box. We can say minimum box loss, although normally it's not necessary to check that, but when losses are critical, then we can have the minimum box loss, which will give us the largest box and the lowest inlet velocity. The aspect ratio we can change if we want to. So a higher aspect ratio means a very wide, thin inlet box, useful for when the shaft has to pass through the inlet box. Or if we want a squarer inlet box, which is more economical as regards material usage, but has a slightly higher loss, we can select an aspect ratio down to 2.5. We can add losses for silencers. So we just enter our estimate of a value there. We can add evases, change the area ratios, and specify the efficiency of the evase or diffuser. So let's just use the inlet box and inlet damper for now. The inlet damper, because it is on an inlet box, will be a pre-spin type. So that needs to spin the air in the same direction as the impeller rotation. Now we can press F1 on the keyboard here and bring up Centrix Help at any time to explain things like aspect ratios and so on. So let's click Next now and have a look at the fan type required screen. So we can see that the types to select is all types. We can drop that down and look at various types such as backward types. We can look at single widths or double widths, and if we know exactly which fan we want to look at closely, we can drop that down and just select one of these particular designs here, or two of these designs. So we could say clear all and let us only look at the BC219, say a BC317 and a BL245. So let's just move that back now. The speed options, we're going to look at any speed within this speed range. So we've got 3,800 RPM as the maximum and 100 RPM as the minimum. We have a minimum efficiency set here of 70%. Now we can set this lower if we're not sure that we are going to get a selection, because this will prevent selections with lesser efficiency than this, but that is before the accessory losses are included. So we might say 50. We're going to fix the width to 100% to start with, and we will include any over or undersized fans where we have larger or smaller impeller diameters in the same casing. The maximum tip speed override is 200 meters per second. Each design has warnings on tip speeds where the high stresses for such a tip speed may require special construction or special materials. Our range pressure here, 95% down from peak and 95% of the available curve. So I might just go into the maximum range pressure in a bit more detail later, but for now let's say we'll use Reynolds number, we'll use compressibility effects, and we'll click Next and see how many selections we get. So we found 16 selections with that criteria. So all we need to do now is we can glance at the efficiency. We have some at 75%. So we might say, okay, well that's the only ones I'm really interested in are above 70%, so I can reselect and get rid of all the less efficient fans. So I can then sort, say, by fan size. So that is then the smallest fan with an efficiency of 67%. Now that is below 70 because of the inlet box and inlet damper losses. So I can double click that one and show the fan performance curve.